Okay, in this example, our tangent line problem is just slightly different than it was before. Now, we're going to be asked to find the equation of the line tangent to the curve y equals x squared minus 5x through the point 3, negative 6. So not only are we going to have to find the slope using our limit formula for the tangent line, but we're also going to set up the equation of the line. We're going to start it with the point slope form and eventually write it into the slope intercept form of y equals mx plus b. So we'll start here with our equation right here, and of course we know how this one goes now. Since we're saying that our function f of x is the function x squared minus 5x, right now we're given the information that if we take f of 3, we do get negative 6, and you can see that if you take negative 3 squared, that's not, if you take 3 squared, that's 9, minus 5 times 3, that's 15. 9 minus 15 would be negative 6. Alright, now the only other quantity we need, of course, is going to be our f of 3 plus h in order to get this formula out, so we'll write it 3 plus h squared minus 5 times 3 plus h. And that's what's going to go into our formula up here. So we're going to go ahead and write this out. We're going to take the limit as h approaches 0 of the quantity 3 plus h squared minus 5 times the quantity 3 plus h. And we're going to subtract from that our f of a value, that's negative 6. And we're going to divide the whole thing by h. Then we're going to have to simplify. So in the numerator, a little bit of algebra is necessary. We're going to have to square the quantity 3 plus h. I won't work that out for you word for word right here. I'll just show you this one comes out to be 9 plus 6 times h plus h squared. And you should, if you want to, stop this recording and verify that for yourself. I'm going to distribute the negative 5 into the parentheses, so I'll have minus 15 minus 5h, and minus negative 6 is the same thing as plus 6. All of this is divided by h, so now let's simplify down. 9 minus 15 is negative 6 plus 6. All of those go away right here, and we're left with 0. So this actually becomes our limit as h approaches 0 of 6h minus 5h, that's 1h plus h squared, all divided by h. Factoring out the h from the numerator in both terms, we get h times the quantity 1 plus h, all divided by h. The h's here cancel, and so we're left with the limit as h approaches 0 of 1 plus h. If we let h go to 0, of course, we just get 1. That's our slope. So in this point slope formula right here, our point x1, y1 is going to be the point 36, negative 6 right there, and the slope is equal to positive 1. So really this is just sort of a fill-in-the-blank type of formula, where y is the variable, x is the variable. On the other side of that equation, we would write the following. Y minus y1, which we now know to be negative 6, is equal to the slope 1 times the variable x minus the value x sub 1, that's 3. And we're going to simplify this down. This is the same thing as y plus 6 equals 1 times x minus 1 times 3. We subtract 6 from both sides, and we get the equation of our tangent line, which is going to be 1 times x minus 9. If we were to plot the line y equals x minus 9, and the curve y equals x squared minus 5x, this value, this equation, would be tangent to the curve at the point 3, negative 6. That's what we wanted, and so we're done.